Hey guys, I am here today to talk to you guys about bonding and Lewis dot structures. So you should learn about bonding in those interactives that you did yesterday, ionic and covalent. There's actually another type called metallic that we're not really going to focus on, but there are those three main types. So like I said, there's ionic and covalent, and those are the two pretty big ones, important ones. For us, because they are the ones that are involved in most of the biology stuff that we're going to be talking about next year. It's almost all ionic and covalent. An ionic bond will occur between a metal and a nonmetal. This is where electrons are actually exchanged. Hey, nice job. And that's my daughter. I'm so sorry. Okay, so electrons are exchanged and they'll create the ions. So either those positive or negatives. If you remember, the positives are cations, the negatives are anions, because cats have paws, so they're positive. So an cation will lose an electron, an anion will gain that electron, and then that opposite attraction between a positive and a negative is what will form an ionic bond. Covalent are also called molecular bonds. These are going to be between two nonmetals, and nonmetals, if you remember, are the ones that form anions. So we don't have a positive or a cation in this case. It's all negatives, which is why they have to share the electrons. So instead of being able to exchange, give or take electrons, they have to share them. By sharing, it creates a very stable attraction between positive nuclei and the negative electrons. But these do tend to be weaker than ionic bonds because sharing is a little bit harder to do. The electrons have to stay in a very specific place where they don't really have to do that when you're talking about exchanging electrons. But if you look at this top picture here, you can see that all the electrons between the oxygen and the carbon are going to stay in this very small location between those two nuclei. And the same thing between this other oxygen and this other carbon. So these are the ones that are being shared. And then down here, we've got our example of two fluorine atoms sharing some electrons right there. What the goal of all of your electrons are, or all of your atoms are, is to form what we call an octet or 8. They want to have 8 electrons around them. So if you're looking at sodium, it's got valence electrons of 1. Chlorine has a valence electron of 7. So this sodium will actually give up this electron to the chlorine. So that chlorine has 8, and sodium then loses that 1 so that it drops back down to its next energy level. And then it'll be a positive and a negative, forming that electrostatic attraction, keeping them together. So the reason that they want this octet is so that they can be like the noble gases. I always call them wannabes, like I want to be a superhero or I want to be a super fast runner. Doesn't necessarily mean that I am actually a superhero. I am not really Wonder Woman, even if I want to be. But they do try and look like that, just like if I dressed up.
I want to be Wonder Woman.
Just like if we dressed up for Wonder Woman on Halloween, I am still Mrs. Weisman. That would still be Evie on the inside, but on the outside we might look like Wonder Woman. So on the inside you've got sodium, on the inside you've got chlorine, but on the outside they might look like a noble gas because they've gotten that octet. If you're talking about electrons that are not involved in bonding, we don't draw them. So you're only talking about those valence electrons that you want to draw around a central atom. So Lewis dot structures are a way to show bonding between two elements. Every element wants to follow the octet rule except for hydrogen, because hydrogen is so small. It can only hold like 2 or no electrons. So if it has 2, it is happy. All the other ones need to have 8 around it.
Mommy, look.
I know, you did so great.
Mommy, look.
These are all of the steps for writing or drawing Lewis dot structures. So first you want to draw the skeleton structure, or what it just looks like with its valence electrons, so like the 1 dot or the 2 dot, maybe 7 if we're talking about chlorine. So in order to do that, you find the valence or bonding electrons. You use the numbers that I gave you on your periodic table, or the ones that we learned about in our last lecture. Then you need to connect the atoms together. So you're going to draw a line between the 2 atoms or 3 atoms, depending on how many there are. One line will equal 2 electrons. You need to then place the remaining electrons around all of the atoms and count them up so that you can tell if each atom has 8 electrons or not. If they do not have 8 electrons, and we probably did something wrong, maybe we need to do a double bond instead of a single bond, so it'd be 2 lines instead of 1.
Papa.
Beautiful. Yes, honey, they see it. She's just showing you her flower. So I've got some practice here that I would like you to do. If you could pick out 2 of those and draw Lewis structures for them, take a picture and send it to me so that I know how you guys did. I have posted another video that is not me, but somebody else explaining Lewis dot structures, so that you can give it a try as well, and hopefully that'll help you understand what's going on when we do Lewis dot structures. Let me know if you've got any questions.